Morning, everyone. This is another wonderful day to study algebra. It's really the day that the Lord has made, and we will rejoice and be glad in it, even if we have to study algebra. I have a couple of lame jokes for you today. Sometimes the best lame joke books are the old ones. Sometimes they're just dumb. I guess the definition of lame joke is dumb anyway. Question: what kinds of sandwiches do sharks eat? They eat peanut butter and jellyfish sandwiches. And then can you tell me what is smarter than a dog that can count? A spelling bee. So, see if I can get this in the camera. First off, what we have right there is our peanut butter and jellyfish sandwich by the shark. And there is the bee on its way to the spelling match, showing that it's able to spell quite adequately. So, we're back with pre-algebra. We are using as our text Bob Jones pre-algebra for Christian schools. As long as you have a standard pre-algebra text, you can follow along with us. In this particular text, though, we're in section 2.6. We're talking about solving equations using multiplication and addition. And I think I'm going to try this a little bit differently. I'm going to track more directly. I'm trying to explain to you what the book itself is saying. You can use inverse operations to solve equations involving multiplication and division. And we've talked about inverse operations a lot already. And what those inverse operations are, they can undo one another. Let me show you what we have here. If we start with 5, starting with the number 5, we're going to say, okay, well, first I multiply by 5, except I didn't want to say 5, I wanted to say 3. It's a little bit too early this morning. If we multiply by 3, and then divide by 3, let's see what happens, because I said multiplication and division undo one another. So I did multiply, and then I divided. Now how are we going to solve this statement here? Well, our order of operations says multiplication, division first, in order from left to right. So even though we don't have to put in parentheses, I'm just going to put in parentheses to make it real obvious that we're saying 5 times 3. 5 times 3 is 15. And now we divide by 3 again. And this is the work that you would want to show on your paper. You want to be very methodical, step by step, going down the page, not across the page. Now, what is 15 divided by 3? Well, of course, that's 5. What did we start with? We started up here with 5. What did we end up with? We ended up with 5, so that we see that multiplication and division are inverse operations. When you start with a number, or start with an expression like we did here, with 5, and you multiply and divide by the same number, those operations undo one another, and you end up, as I have erased, all of that little in-between workup, end up with no change. The expression that you start with, now we're going to say times 3 divided by 3, 15 divided by 3, gets us back to that same value of 5 that we started with. So that's an example of how division undoes multiplication. Now let's do one where we see that multiplication undoes division. Start with this number 6. So, okay, what I want to do let's go ahead and divide by 2. If we mean that multiplication undoes division, we already have division by 2. See what happens when we multiply by 2. Order of operations says multiplication and division in order from left to right. Division, multiplication, they're the same level of priority when it comes to solving an expression. So we do them in order from left to right. 6 divided by 3, 6 divided by 2 is 3. Then we write the rest of the expression, 3 times 2. What is 6 times 2? 6 times 2 is 3. What you see going on here is an example of the fact that division and multiplication are inverse operations. When you multiply and divide an expression by the same number in sequence like we did here, you have no value, no lasting effect on the number that you're multiplying and dividing. We started right here with a 6, and we ended up with 6. And that's what the principle of using inverses when you are solving equations is just absolutely fundamental. You have to be able to do that, and that's what makes algebra work. And it goes off of the fact, the illustration that we talked about, that equations are like a scale, like a balance beam scale, which you may have known in science, or if you don't know the idea of a balance beam, it's like the idea of a seesaw. You can keep that thing balanced, and as long as you do the same thing to both sides of the equation, if you subtract weight from one side of the equation, subtract weight from one side of the balance beam, your seesaw is off level. But if you take that same amount of weight off the other side, then your seesaw is still in balance. If you've got 2 kids on each side that weigh the same amount, one kid jumps out, seesaw's not balanced. But if the other kid jumps out from the other side, it's back in balance. And that's what we're trying to do when we solve these equations. As long as you do the same thing to the right-hand side of the equation as you do to the left-hand side of the equation, while your equation may look different, it's still in balance, and that's all that's necessary. So let's go ahead and consider 15 times 15. Where 15 equals 15. If you do the same thing to both sides of the equation I just said, it might look different, but it's going to be still balanced. So let's say I'm going to multiply the left-hand side of the equation by 15. In order to keep it balanced, what do I have to do? I have to do exactly the same thing that I did to the other side. We multiplied it by 2. They say, Miss Betsy, it's not the same. It's out of order. It's okay. Remember that multiplication is commutative. It doesn't matter which of the 2 factors you place first. 2 times 5 should be, 2 times 15 should be the same as 15 times 2. 2 times 15 is 30. 15 times 15 is 30. So when you multiply both sides of the equation by the same number, it stays the same. What about when you divide both sides of the equation by the same number? Here's example 1. Here's another example. If we start off saying that both sides of the equation have the same value, it's obvious right now that they do, because we're not talking about any variables. We're just talking about the number 15. 15 is equal to 15. Okay, if you've got 15 marbles and he's got 15 marbles, you have the same amount of marbles. Now what happens if we divide one side of the equation by a 3? As long as you do the same thing to both sides of the equation, that equation stays in balance. I've divided the left-hand side of the equation by 3. I need to divide the right-hand side of the equation by 3. And I end up with another true statement. It is true that 15 is equal to 15. 15 divided by 3 is also equal to 15 divided by 3 because 5 is equal to 5. And this is what they're leading up to here. They call the multiplication property of equality. And while they want you to know what this property looks like, they are really much more interested in you being able to work with your multiplication property. They're much more interested in you being able to work with your equations based on this property. This is called the multiplication property of equality. It's also the division property. Same thing, just like we have addition and subtraction, multiplication and division. This says we're going to take any numbers, doesn't matter what the numbers are. The number's going to be A, B, and C can't be equal to 0. We're going to say if A is equal to B, then A times C is equal to B times C. And I'm going to go ahead and write down here AC is equal to BC. I'm talking about all real numbers. Doesn't matter what you start with. Start off saying that, or A can be anything. If A and B have the same value, for example, 3/6 is the same as 1/2, right? We have two different values here. Two different appearing sentences, two different appearing expressions. 3/6 and 1/2 don't look the same, but if you have a pizza and you cut it into 3 equal slices, and you eat 3 of those, you've eaten the same amount of pizza as if you had that same size pizza cut into 2 equal size slices and you eat 1 of them. These are equivalent expressions. So, if A and B have the same value, you multiply both of sides of that equation by some value or some expression. It's the same, C is the same. Then that equation is still balanced. If A is equal to B, you multiply both sides of the equation by another number, then your resulting values on either side of the equation are the same. The same thing over here. If A is equal to B, you divide both sides of the equation by a number, then this is a true expression also, every time except 1. Now over here, A, B, and C can be any numbers, right? It can be anything. When you're multiplying. Are there any values over here that you can't use for C? Well, yeah, there are, and you're going to learn to make this recognition automatically. You cannot divide by 0, so you have to put this little, oh, by the way. C has to be different from 0. This says C is not equal to 0. Some teachers say C can be anything except 0. C is different from 0. That means the same thing, that C cannot be equal to 0. This is the multiplication and division property of equality. Multiply both sides of the equation by the same value. The equation is still in balance. Division property of equality, start with something that's equal to one another. Divide both sides of the equation by the same expression. As long as you're not dividing by 0, by something equal to 0, then your equation is still in balance. And that's something that is just so very, very valuable. What your book says on the bottom of page 56 is, what do you do if you're going to solve equations using multiplication and division? First thing you have to do is figure out what's happened to the variable. So if we have solving equations, using multiplication and division. Multiplication and division. First, what's happened to the variable? What's been done to the variable? And then the second says, use the inverse to undo this operation, multiplying or dividing both sides of the equation by the same number. So you're going to use the inverse, if I can remember to put an S in there, inverse on both sides of the equation. Maybe this sounds like so many words that mean nothing. Easy example here says, let's solve this equation. Solve for x. 3x is equal to 6. Now you're not allowed to just look at this and say, well, obviously x has to be 2 because 3 times 2 is 6. Yes, we all can look at this and say 3 times 2 is 6. What you have to learn is the method to solve this equation. First, what's it say? It says what's been done to the variable. You have the x all by itself to begin with. What did they do then? They multiplied it 3 times x is equal to 6. So variable was multiplied by 3. Okay, we make sure that this is still showing. I can't see the screen completely. Variables multiplied by 3. Find the inverse operation, do the same thing on both sides of the equation. What's the inverse of multiplication? Yeah, it's division. So you divide both sides of the equation by the same value. Divide by 3. 3x divided by 3 is equal to 6 divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. You know how to cancel common factors. Let me move up and see if I can see this. And you're going to end up, let me write it over here so it stays in the screen. You don't do this, but since I ran out of visible chalkboard, 3 times x is equal to 6. We realize that you multiplied both the variable by 3. This side over here hasn't been multiplied by 3, but that's not what we're looking for. All we're looking for is what's been done to the variable. It's been multiplied by 3. Now we take the inverse operation, which is division. We're going to divide by that same number. So we're going to divide by 3. To keep our equation in balance, you have to divide both sides of the equation by 3. You end up with x is equal to 2. We already knew by looking at this that x was going to be equal to 2. This is how we solve that equation. You must understand how to solve it this way. Period, end of story, because you are going to have expressions very, very quickly that you cannot just look at and say, oh, by the way, the answer to that is 17.26. Or the answer to this is a minus 3/10. Okay? But by learning how to use inverse operations, it's very easy to come up with an answer. Oh, well, the answer there is 7/3. Something that you would never look at and automatically come up with the answer. Okay? Let me erase this. Let me do another one here. Let's solve this. This is example 2. 171 is equal to 3x. Now you might look at that and say, that's wrong. It's got the variable on the on the right-hand side of the equation. Doesn't matter. An equation that's in balance, the variable can be on either side. Two ways that you can look at this. If you really hate the fact that the x is on the left-hand side of the equation, turn the equation around. So here's going to be plan A. And you know what? I'm going to rewinding that. I'm going to say plan A is to solve this equation exactly as it's written. 171 is equal to 3x. I may have called that A, but that's an x. The equation's in balance. First we identify the variable, 3x. This is the term that contains the variable x. What have they done? What operation has been performed on that variable? Well, it's multiplied by 3. So multiplication is the operation. What's the inverse of multiplication? It is division. So we're going to want to divide by 3 because we've multiplied by 3. Our equation's out of balance. The only way we can do that is to divide both sides of the equation by 3. You cancel common factors. Maybe you can divide this in your head, maybe you can't. Do not use a calculator. I'll show you long division. 171 divided by 3, 3 times 5 is 15. 2, bring down the 1, and 7. So what you have here is that x has a value of 57. It's in balance, so it doesn't matter if you read from the front or the back. You can just as easily say x is equal to 57. Both of these are legitimate. They mean exactly the same way. Let's say, oh man, Miss Betsy, I cannot get my mind wrapped around the idea that I've got that variable over there on the right-hand side. Is there any other way I can do it? Well, yes, your equation is in balance. When one side is equal to the other side, it doesn't matter how that equation is written. So you can also do it this way. Plan B. You've started with 171 is equal to 3x, but you can just go ahead and rewrite that as 3x is equal to 171. If it makes your mind happier to see it written like this, then you're following the same process. What's been done to the variable? It's been multiplied by 3. Since it's been multiplied by 3, the inverse of multiplication is division. So you divide the left-hand side of the equation by 3 because the variable x has been multiplied by 3. To keep the equation in balance, you divide both sides by 3. You do your division, and you have x is equal to 57. This is what we're working with for now and forever through your math. You're always going to be solving equations this way. Let me show you one more. Let's take we'll do an easy one first. This is problem number 2 from your homework, except I gave you the odd problems. We have 7m is equal to 84. It's a very atypical looking m. 7 times m is equal to 84. Did you hear what I said? I said 84 and I wrote an 81. The variable has been multiplied by 7. The inverse of multiplication is division. So I've multiplied by 7, I have to divide by 7. And now, to keep my equation in balance, I have to divide the right-hand side of the equation by 7 also. Common factors cancel. M is equal to 12. go ahead and do that long division. If you can do it in your head easily and accurately like I did, that's just fine. If you can't, you can prime factor this and cancel common factors, or you can do the long division. Either of these methods work, whichever you prefer to use is fine. In this case, I would tend to do long division, but let's just say that you wanted to prime factor this. I see that's 4 times 21, 2 times 2, times 3, times 7. We prime factor it. 2 times 2 times 3 times 7. And you can rewrite 84 over 7. Let me show you this way. We've already canceled. M is equal to 84 over 7. Here we have our prime factorization. 2 times 2 times 3 times 7. Now we have a common factor of 7 that we cancel. What we have left, 2 times 2 is 4, times 3 is 12. Two different ways to come up with the answer. The third way is to use a calculator. You're not allowed to use a calculator. Fourth way is to ask mom or dad. Not allowed to do that. You can either use prime factorization so that you can cancel common factors, or you can just do the long division where you divide by 7. Okay, let me pick another one here. Let's look at number, what do I want to do? How about number 14? This one says m divided by 3 is equal to 65. Misspoke again, we'll go with 63. So let me change that just in case you wanted to make sure that I did exactly the same problem. M divided by 3 is 65. The variable has been divided by 3. You have to multiply both sides of the equation by the very same value. Multiply both sides by 3. We have a common factor of 3 that cancels. We have that m is equal to 195. Off to the side, you have 65 times 3. 3 times 5 is 15. Carry 1. 3 times 6 is 18. Plus 1 is 195. For those of you who might be interested in mental arithmetic tricks, you can think of this as that 3 times 65 is the same as 3 times 60 plus 3 times 5. 180 plus 15 is 195. Don't expect any of you to do it this way, but this is how it's easy to break multiplication up of small numbers in your head. You multiply the tens, you multiply the units right here, and this is exactly using the distributive property from section 2.4. And I believe that's all that I'm going to do. Let me look at this and make sure. Let me go ahead and do number 22. Just as another example for you. Number 22. This says 3n is equal to 83 plus 46. When you look at this, what would you think you need to do first? Well, hopefully you would think, oh, I need to add 83 and 46. You do, because you have to combine. You have to do whatever simplification you can do. Perform any operations that are there to be done before you continue. 83 plus 46 is going to be 129. 6 plus 3 is 9. 8 plus 4 is 12. So you have 3 times n is equal to 129. Get it down to this form, and now we see what's happened to the variable. We've multiplied by 3. The inverse of multiplication is division. We multiplied by 3, we're going to divide by 3. And to keep our equation in balance, since we divided the left-hand side of the equation by 3, you have to do exactly the same thing to the right-hand side of the equation. We've divided by 3. And n is equal to 43. That's the end of section 2.6. I hope this helps you, and I'll see you next time.